Welcome back to Boiler Wild. My name is Eric Johnson. On this podcast, talk about boiler industry topics as well as personal development. If you don't already know, if you're the first time listener to this podcast, Boiler Wild, you may be asking yourself, that's an interesting name. WILD stands for work hard, invest yourself, lead others, and develop yourself into a person of excellence. Always striving to get better, far from perfect. You are far from perfect as well. Nobody's perfect, but the pursuit towards perfection is the goal. What I'm going to talk about today, first things first, housekeeping item. Thank you everyone who has rated the podcast 5 stars. The one person who rated the podcast 4 stars on Spotify, you're dead to me. That's all right though. I'll take it. That just means I need some improvement, but you didn't leave a comment, so I don't know why I only got 4 stars instead of 5 stars. But everybody else that's gotten 5 stars, that is great. Everybody on Apple Podcasts, you need to catch up. But if you are listening to this and you enjoy this podcast or any other podcast episode, please rate this 5 stars on your podcast app. That would greatly help me and help other people find this podcast, trying to educate others, put some new perspectives into you and other people, and also highlight other people in the industry who are doing similar training things or HVAC boiler stuff, and highlight their experience, education, and insight and experiences for you to hear so that we can all learn from it. So that is the goal. Today, we're going to talk about what to do when your boiler doesn't start. So this is a common problem. You can walk into a boiler room and there's no alarm. And depending on the burner control and like what is controlling the boiler / burner, you can look at it and say it's the Honeywell 7800, the blue box, and it's just sitting there in standby. Yet the boiler's not running, and there's no steam pressure, or there's no hot water. And a operator may be wondering, well, why is my boiler not running? There's no alarm. It should be running. There's no hot water. There's no steam pressure. Steam pressure is 0. Why is it not running? So that can be confusing. So I'm going to talk about that and educate you, and hopefully you learn something. And if you don't learn something, well, then you're already a pro and you're educated. So share with others then. So what to do when your boiler doesn't start? So first things first, we need to go over 2 terms, recycle and non-recycle. These are general industry terms, and recycle means that when a limit opens, and by limit, I mean some kind of control that either limits pressure or temperature or level, like water level. When a limit opens, which is just going to be a switch, when a switch opens and then it closes again, the burner can start. So an example of this would be a primary low water cutoff. The boiler is running. You turn off the feed water pump. The water level in the boiler starts going down a little bit. It finally trips the primary low water cutoff. The boiler is going to go into post-purge and shut down. You turn on the feed water pump, and then the water level is going to raise up in the boiler and is going to go to the normal water level. And in that process, it is going to remake the primary low water cutoff, which is going to close, and it is going to allow the boiler to automatically start again. That is just an example, and that example assumes, that is not universal, but that assumes that the primary low water cutoff is wired in a recycle circuit for the microcontroller, which is the general term for what a Honeywell 7800 is, or a FireEye, Burner Logics. Those are microcontrollers. Inside of them are just, now, they used to be physical relays and cams and stuff if you look at the older ones, but now they're just circuit boards with little microcontrollers and little relays soldered on them, and you power them up, and then they send power in and out based on the microcontroller logic. Non-recycle means that when a limit opens, so when a switch opens, so if our secondary low water cutoff opens while the boiler is running, it is going to shut down the boiler and it is going to produce an alarm. Even if the water level keeps rising and goes back to normal in the boiler, in this case, the manual reset doesn't have to be on the secondary low water cutoff, but it commonly is. But it can close, but the microcontroller, the burner control, will not start again. It will be in alarm state and has to have operator intervention, which is going to be pressing a reset switch. So once again, recycle means it will automatically shut down the boiler when the circuit opens, and then when the circuit closes, it will automatically restart the boiler. Non-recycle means it will automatically shut down the boiler when the circuit opens, but it will not start the boiler without operator intervention from a manual reset switch after the circuit is closed. Why does this matter? So the most famous, the most well-known recycle is going to be on a steam boiler, is going to be your operating pressure control, and on a hot water boiler is going to be your operating temperature control. This is going to be for your steam pressure, for your normal steam pressure. So say, we're just operating at 10 psi, and at 10 psi, we're going to shut down. So the burner runs, it makes pressure, it hits 10 psi, the operating steam pressure switch opens, and the boiler goes to post-purge and shuts down and goes to standby. That is normal. If you were to wire your operating pressure control switch into a non-recycle circuit on the microcontroller, every time your boiler hit the set point that you were trying to control to and not go above, which in this case is 10 psi, every time it hit that set point, you would have to go in and manually reset the boiler. And I have seen this done by people who didn't know what they were doing, and they typically end users, and they ended up wiring their boiler or like messed up some wires. And they said, the boiler runs, but every time it shuts down, we have to reset it before it restarts. And they had wired the operating pressure control switch in the wrong circuit. And I can't tell you what that circuit is. It's going to be different based on your microcontroller, which is the burner controller, and the brain of the burner / boiler of what is controlling the operation of it. For the Honeywell 7800, you will have a terminal with the description burner controller and limits. That is going to be your recycle terminal. In this case, it's terminal 6. Terminal 7 is lockout running interlock. So if power is removed to terminal 6, which is the burner controller and limits, that is going to be the recycle circuit, and the burner controller, in this case the 7800, is going to be able to restart once power or voltage is returned back to the input of terminal 6. Terminal 7, if voltage is removed from terminal 7 while the boiler is running, the lockout running interlock circuit will cause the 7800 to go into alarm and require a manual reset from the operator before the boiler can run again. For the FireEye Micro M series, I think it's MEP, forget what it's called, but you will have just a typical operating control circuit, which is going to be coming in on terminal 7, and then which is going to be your recycle circuit, and you can put as many limits as you want and switches as you want in that circuit, and they're all going to be wired in series. But anytime that those open, you're going to remove the permission for the burner to run, but it is not going to produce an alarm. But on terminal 6, which is your interlock circuit, is going to be as many switches as you want. They're all going to be wired in series, but if one of them opens, it is going to produce an alarm, and that is going to shut down the burner and require a manual reset. If you are familiar with FireEye, the burner logics, or other controllers that have the 3P interlock, you will have, well, first of all, you'll have the recycling interlocks, which once again is going to be the operating pressure control or any other control that, say, like the burner switch, in order to give permission to the programmer or the burner control or the microcontroller, give permission to it for it to run. If you have a 3P alarm, that is going to be a non-recycling running interlock, and that is going to be any interlock that is wired in series between terminal 3 and terminal P, and once again, this is only on FireEye, terminal 3 and terminal P, and if that circuit opens, you are going to have a alarm that is going to require a manual reset. There's no hard and fast rule of what needs to be where. It is going to depend on the burner manufacturer. For controllers that have less inputs, so this is going to be the Honeywell 7800, the FireEye burner logics, the FireEye Micro M, any sort of controller that is similar to those. They have a set amount of inputs and outputs, and they don't have as many inputs and outputs as, say, a parallel positioning system or a PLC system. So for the limited input and output controllers like the Honeywell 7800, you only have one input for that recycling operating limit. So everything is going to be wired in series. If you're unfamiliar with series wiring, that's going to be like daisy chaining. So say we would have the burner switch. So it's just going to be one contact burner switch right on the front of the burner. And then right after that switch, we would connect that to the operating pressure control. And then right after that operating pressure control, we could connect that to the low gas pressure switch. And then right after that low gas pressure switch, we could connect that to the primary low water cutoff. And then after the primary low water cutoff, we could connect that to the draft control switch. And then after the draft control switch, we could connect that to the combustion air louver proving switch. And then we would connect that down to the Honeywell 7800 recycling limit terminal. And if any of those switches that I mentioned open, that series circuit is going to stop the voltage from hitting that terminal on the Honeywell 7800 or any other controller that you have. It doesn't matter. I'm just using the Honeywell 7800 because it's typically the most common one people see. It will stop the voltage from hitting the input terminal of the Honeywell 7800 for the recycling limit, and it will tell the Honeywell 7800 to go into post purge and then to shut down the boiler / burner. And it doesn't always go into post purge. That is just assuming that if it's already in an ignition state, if it goes to pre purge and you remove it, it's just going to go shut down. That's going to differ based on the logic of how the controller works, but that doesn't matter. We don't have to get into the specifics of that, but it just, think of the recycle or the operating limit as permission to start and stay running. And that is what is going to stop your boiler from starting, but it is not going to produce an alarm. The non-recycle are going to produce an alarm. Now, another example that you need to be mindful of is if somebody else is resetting an alarm, or if you accidentally reset an alarm on your controller. But for this mythical boiler that we have, if you have a secondary low water cutoff, and that is required to have a manual reset, typically the manual reset will also be on the secondary low water cutoff, and it will be on the burner controller. So you'll have two manual resets. You can reset the manual reset on the burner controller, and the water level has returned to normal in the boiler, and now the boiler's not starting and it's just going to sit there. You also have to identify through some little voltage checking, if you weren't aware that it already tripped or there's no indication that the secondary low water cutoff trip, you would have to check your voltage through your circuit looking at your wiring diagram, but you would also have to reset the secondary low water cutoff switch. So just be mindful of that. It's not always, hey, my boiler's not running. It's going to be the recycle, the operating limit. Sometimes how the boiler's wired, especially if somebody else is in there and resets it and now it's not running. It can be in the non-recycle part, but they've already reset the burner controller, but the switch in itself that tripped also needs to be reset. A typical scenario where this is an issue as well for service technicians is you go out to a site for an annual inspection, the boiler gets opened, maybe there's some tubes that need to be replaced, and they hydro the boiler. So by hydro the boiler, it means they filled the boiler up with water 100% of the way, and then most often you can just use the pressure of the feed water pumps to add pressure to the boiler to see if the repair are leaking. So the new tubes are leaking, or if any other tubes are leaking. If that is not satisfactory for the situation, you need a pump that is going to be able to pump up the boiler to a certain pressure, and that is going to depend on the MAWP of the boiler. But anyways, you pump that up, and if you pump up the boiler to the MAWP, you will probably trip the high pressure limit on a steam boiler. So the people who did the tubes hydro it, they say, yep, it's good to go. Then they drain it down to normal water level, drain all the pressure off, and then they leave. Service technician comes back. They finish closing up the boiler, whatever they have to do. And then they turn on the burner switch, and the boiler just sits there. They're like, well, I have gas. Everything's good to go. What's going on here? Then, you got to pull out your meter. And of course, it's probably Friday at 2:00. You're like, it's giving me issues here. And you start troubleshooting. And then of course, you're an expert troubleshooter, and you have a perfect wiring diagram that's laminated and correct for the equipment in front of you. So you can easily find the issue, and you look at it, you check a couple terminals, and you're like, high pressure limit is tripped. So you reach out, you push the little button on the front, the little red button, typically on a Honeywell pressure troll for a manual reset. You push the little red button, you hear a little click, and then you hear the blower motor start, and everything is good to go, and you ride off into the weekend like a happy sailor. So that is a common situation when the boiler is hydroed. The high pressure limit will trip, and typically the people who hydro the boiler can be different, or even if they're the same people who start the boiler. And it's easy to forget that the high pressure limit tripped when you hydroed the boiler, and now you're wondering and trying to troubleshoot why your boiler doesn't start. But typically, it's not going to produce an alarm on most boilers. If you have a parallel positioning system or a PLC system, the more complicated systems are typically easier to troubleshoot because they have more inputs and outputs. And instead of having a bunch of limits wired in series, you can have one limit wired for every single terminal. So your low gas pressure switch is wired to 2 terminals on your controller. Your high gas pressure switch is wired to 2 terminals. Your high steam pressure switch is wired to 2 terminals, and so on and so on. So that if the boiler isn't starting, the display can show, hey, this switch and this switch are open. And even if there's an input and output, like green and red lights, they can do that as well. Or they can produce an alarm and say, low gas pressure switch open. Those are all different scenarios for being able to better troubleshoot the issue. But you just need to remember that there are recycle limits and non-recycle limits. But on the more complicated systems, they will typically tell you, hey, this is what opened. Also, another note that you need to be mindful of is when you walk into the boiler room and the boiler's not running and you've already determined that you're in a safe environment and you've looked over the boiler and it seems like it's ready to go and everything's normal and the customer hasn't done any modifications or repairs, you're not coming back from anything abnormal, it just stopped running. Don't go around and push all the resets. So if you have a series circuit and you have 4 limits in that circuit and you just push all the resets on the limits that you know have resets, and then the boiler starts, you don't know exactly what limit tripped if the boiler doesn't start right after you push a reset. So that can be tempting to do, but you need to make sure that you are mindful of pushing resets, because typically on a Honeywell 7800 or like a FireEye Burner Logix, you will not have a, hey, this is open or this is open. It will just be, hey, the burner's not running, or it's just, it's just sitting there and it's not going to tell you. So if the alarm doesn't tell you what it is and you just push all the resets and then the boiler starts again, now you don't know what tripped and now you're just guessing. Typically though, if you still got good feeling in your hand and maybe some good hearing, if the boiler room is decently quiet, you can hear when a switch resets or feel when a switch resets. But I have watched boiler operators think that in order to restart the boiler, they have to go around and push all the resets. Or even service technicians, they go around and push all the resets before they start a boiler. And that can mask problems when you are pushing all the resets before you start a boiler. Another common issue with the boiler not starting is your combustion air louvers. So combustion air louvers, if they move, are required to be interlocked with the recycling permission circuit, the operating circuit of the burner. So the burner cannot start until the combustion air louvers are proven open. Nobody appreciates the combustion air louver damper. It's typically just tucked away on the wall and nobody looks at it. And the linkage can fall apart, the end switches can fall apart, the motor can stop working, the motor can leak and have the wiring get filled with water made from some rain, and the breaker can trip. But if that end switch does not make and prove that the combustion air louver is open, the boiler will not start. So you will turn on your burner switch and the boiler will just sit there, because it is waiting for the combustion air louver end switch to make and return that voltage back so that the operating limit terminal on the controller says, yep, all the operating limits are closed. You have permission to start. So it will sit there, and a person who doesn't know what they're doing, or somebody who only looks at the wiring diagram of the equipment and doesn't check the other mysterious wires that come into the cabinet, can get confused, because you can look at the wiring diagram of a piece of equipment. And sometimes they will have, hey, wiring your combustion air louver switch here on the burner, or your e-stop switch. That's another one as well. But a lot of times they don't. So when it's wired in, it's just kind of made up where it's wired in and it's added. Sometimes they'll write it on the wiring diagrams. Sometimes they don't. But, you know how it is. The boiler's installed in 1970. The wiring diagram is long lost. You're trying to troubleshoot why the boiler isn't starting. You just have to find your power and find your operating circuit, and you start looking from there. And there's different ways to go about that based on the boiler, but you should always be mindful of other pieces of conduit coming into the boiler. And you can obviously notice this because there's conduit coming into the panel of the burner. And you can look, and if it's like two little wires that are maybe 14, 16 gauge wires, look where those wires go, and they may land in a relay. They may land and just wire nut to two wires coming off a terminal, but follow the conduit, and you may look up, follow the conduit, and it takes 15 seconds for you to find the outdoor air louver that isn't open, and you're like, oh, duh, the end switch isn't making. But if you stay focused on, hey, the boiler's not running, so the problem must be in the boiler, you can easily miss outside issues like the combustion air switch. Another one is just the building management system. Some building management systems have wiring for the start-stop in the burner. Some don't. Some will add relays, like rib relays, onto the sides of boilers. But you need to be mindful of signals from the building management system, and that is going to be like a remote start signal. But that signal is typically going to be wired on a simple boiler. That signal is going to be wired into the recycling operating limit of the burner. And that is going to be the same circuit that your burner switch is on. So it is going to be the local burner switch, but then it's going to be, think of the burner management system, start-stop, as the remote burner switch. And if that relay, if they want to use a low voltage and then wire it to high voltage, they'll use a relay. But if that signal is dropped out or is not sent, or the wiring gets cut or whatever reason, the boiler will not start. If you're in an emergency, you can just, jump out and remove that relay from the circuit and basically start the boiler on local, and the boiler will run. But, you should always make sure that the customer building management system works. You can also have local and remote switches that are going to be 3-position switches, local, off, remote, and that can bring in different circuits based on the position of the switch. I won't get into that because that's more specific to specific pieces of equipment. But you just need to be mindful that just because the boiler isn't producing an alarm doesn't mean there isn't something wrong. Another one that can easily throw people off are draft systems. So if you have an automatic draft damper, the boiler goes to start, but it needs to prove that the draft damper is opening all the way before it starts the pre-purge phase. So the draft damper is typically going to close in the off cycle. So you hit the burner switch, it's a noisy boiler room, and the boiler just sits there. Well, if you don't look up, or if you don't go to the back of the boiler, if the stack is in the back of the boiler, or on top of the boiler, if you got to go to another level, if you don't look at the stack and look at the draft damper, you won't notice that the draft damper actuator and the motor is driving open. And you will notice that, the motor is missing the end switch, or, hey, the motor isn't even moving and the draft damper is closed, or for whatever reason, it's not making the end switch. Well, the burner will just sit there. It has sent the power to the start signal to the actuator for the draft damper. That draft damper has to make that end switch before that boiler is going to start. And the boiler doesn't know anything different. It just says, hey, I'm going to wait for my start signal. If not, I am content to sit here. So then you will start troubleshooting and figure out that eventually that the end switch for the draft damper is not being made. For whatever reason, this is typically either the motor is not getting power or the motor is bad or the alignment on the linkage or something mechanical is off where it's just not making the switch perfectly so that the switch makes and sends the start signal to the burner control. Once again, the switches that are wired into the operating circuit or the permission circuit, some people call it, that is the recycle circuit, can vary, but on like your average boiler, average steam boiler, let's call it, fire tube, but it doesn't really matter, fire tube or water tube. Your average boiler, it can be your primary low water cutoff, your high limit pressure control, your operating pressure control, your low gas pressure switch, maybe like a burner door switch, your draft control switch, your burner switch, combustion air louver, proving switch. Like those are examples of recycle. Now, any of those can also be, except the operating pressure control, any of those could be technically in the non-recycle circuit as well. So it's going to depend on your burner manufacturer, boiler manufacturer, and how they want it wired. The non-recycle is going to produce alarms, which is going to be your running interlock. So anytime these open, there is a problem that must require operator intervention. And that's going to be like secondary low water cutoff, maybe a high gas pressure switch, stuff like that. And once again, parallel positioning, PLC systems, anything that is beyond a simple burner control is going to have more inputs and outputs, and you are going to get more resolution on your error codes and what is going on with the boiler. And that is why typically, if you know what you are doing, you prefer the little bit more complicated boilers and the nicer spec'd boilers, because you can walk up to the boiler and it'll tell you, hey, low gas pressure switch is open. Whereas if you just walk up to a normal boiler with a burner, with a Honeywell 7800, it'll just be sitting there and not starting. And you got to open up your tool bag, get out your multimeter, and start troubleshooting, figure out that, oh, low gas pressure switch is open. Oh, yeah, nobody opened the gas after the shutdown, or, oh, the gas company came and changed out the meter and didn't tell the customer, and it tripped all the low gas pressure switches. Another one, this is a common other scenario that you may come across is on a startup, or this can be in any boiler room, but it's very common on startups where buildings with new equipment, but construction is still going on. If all the boilers are not running and they just sit there, the problem is probably not a boiler problem. It is going to be a universal problem. So if you have all the boilers and the contractor calls you and say, hey, all your boilers aren't running. We came in this morning and all 4 of them are sitting off and they're just sitting there. There's no alarms, no nothing. Get over here now. So typically you can go through on the phone with them before you drive over there, because it's always going to be something dumb, especially with a new boiler. And when all of them are off, that is an indicator that something on the outside of the boilers happened. And on new construction, that can be all the low gas pressure switches tripped because they turned off the gas to make a repair or to change out the gas meter. And they did that at 4 or 5 o'clock in the afternoon. And most people had left, but they interrupted the gas, and now all the boilers shut off, so that when the contractor comes in the next day, they were unaware that the gas was going to be shut off, or maybe they knew, but they don't know that there's going to be low gas pressure switches on the boilers, and all the boilers are off and the building's cold. And they're freaking out. Well, all you have to do, assuming that the gas is, correct, all you have to do is push the manual reset, if there is one, on all the low gas pressure switches, and all the boilers will start again. Another one is water. If you shut off water to a steam boiler room, all the boilers are going to go down on low water, and you have to figure out why I don't have water to my boilers. Another one is electricity. That sounds dumb, but if you get older boilers where all the panel lights don't work and you have no real visual indication that something is on with power and the customer isn't super familiar with their boiler, you can have a power outage and the customer won't realize that the boiler doesn't have power. Ask me how I know. Way back when I was a service technician, remember going out to a school system. They were freaking out. Hey, we had a power outage and now our boiler doesn't run. So I go out there, walk into the mechanical room, and it's an older boiler. I think there was one light on the front. It was probably burned out. Their school maintenance team had been looking at the boiler for hours, and I open up the cabinet and I look at the burner control, which was a Honeywell 7800, and I don't think it had a display. So I just looked at the green power light. The light wasn't on, so I knew I didn't have power. So I checked at the input of the boiler, and I didn't have any 120. So then I went over to the wall and checked the 480. Didn't have any 480 and found out that the fuses had blown during the power outage and they just needed to replace some fuses. So they replaced the fuses and they're like, oh man, we've been working on this for hours. And they had all the covers off of all the electrical switches and they were trying to troubleshoot why that boiler wouldn't run. But they were just guessing. That's why troubleshooting, you always start with, do I actually have power to my equipment? Because if you don't check that and you start going along, especially on series circuits, like a operating limit that is going to be a recycle, if you don't have power on the switch that you're looking at and you check across it and you check at the terminal on the input of that switch and there's no power there, going downstream of that switch is not going to be the issue. You're not going to find it. So you need to go upstream. You need to find where there's voltage, because a lot of people will say, oh, I don't have voltage at this one. It must be bad. I don't have voltage at this one. It must be bad. And they'll just start changing components where the components aren't bad. They just don't have any voltage to them. Then you keep going upstream, and then you find out your control voltage fuse is blown. You replace it, and everything runs on the boiler. So that's why proper troubleshooting procedures are highly necessary. You need to make sure that you follow the procedures. Checking for power and correct voltage may seem unnecessary, and a lot of people get lazy and skip it, but it will bite you when you least expect it. So quick recap: recycle doesn't produce an alarm, automatically starts the boiler again when that circuit closes, typically called a permission circuit or an operating limit circuit. Non-recycle produces an alarm, does not allow the boiler to restart or the burner to restart unless there is manual intervention of the operator. So that's all I have for you today. Episode 64 of the Boiler Wild podcast. If you enjoyed this episode or any other episodes, please rate this 5 stars. And if you're on LinkedIn, you can DM me or email me, eric.johnson@boilerin.com. If you have any feedback or questions or any suggestions for guests or topics, I would greatly, greatly appreciate that. Thank you for listening, and stay wild.